Hey guys, this is Easy to Comp and today we are going to see about the registers of microprocessor 8086. So this is the architecture of 8086. Here we have three types of registers: CS, DS, SS and ES. They are known as segment registers. The second thing comes is AX, BX, CX and DX. These are general purpose registers, and these four are SP, BP, SI and DI. These come under pointers and index registers. We will see a brief introduction about the flags also in this topic. So first of all, we should know what are registers. So registers may either used for holding data, variables and intermediate results temporarily or for other purposes like a counter or for storing different addressing modes. So in 8086 there are powerful set of registers known as general purpose registers, segment registers and pointers and index registers. All of them are 16-bit registers. The general purpose register can be used as either 8-bit register or 16-bit register. General purpose register. It looks like this. It has 4 parts: AX, BX, CX and DX. In main architecture, it is present down here below the internal data bus: AX, BX, CX and DX. So these 4 registers come under general data registers. The letter X is used to specify complete 16-bit register. The whole 16-bit register is divided into 2 parts: AH and AL. H stands for higher and L stands for lower bit. They are divided into 8 bits. This consists of 8 bit. So AH is higher 8 bits and AL is lower 8 bits. So AX is used as an 16-bit accumulator. That is simply a register to store values. BX is used as an offset storage for forming physical addresses in case of certain addressing modes. Offset is a type of addressing mode. It gives you the distance from a particular location. We will study about the addressing modes in detail, then you will understand what is offset addressing mode in detail. The third comes CX. It is used as a default counter in case of certain addressing modes. Counter, that means for increment and decrement of the values. DX, it is used as an implicit operand or destination in case of few instruction. Implicit is again a addressing mode. Here implicit means that it implicitly specify an effective address for either the source or the destination of, it may be data. Now comes segment registers. These 4 are the segment registers which come under address conversion mechanism: CS, DS, SS and ES. So the 8086 addresses a segmented memory. So what is segmented memory? We will see this in detail. The complete 1 megabyte memory which the 8086 addresses is divided into 16 logical segments. Each segment thus contains 64 kilobyte of memory. So these are the segments. First one is the code segment. The second one is the data segment. The third one is the extra segment and the fourth one is stack segment. So code segment, as its name says, this register stores the location of the code. used for addressing a memory location in a core segment of memory where the executable program is stored. Data segment, as its name says, data, so it stores the data. It points to that data segment of the memory where the data is resided. The third comes extra segment. It is another data segment of memory. It is sometimes used to store the code. The fourth comes stack segment, used for addressing stack segment of memory. Now those who don't know what is stack is, we will see by an easy example. Stack is a data structure. It is similar to that of placing a chapati in a box while cooking it. So the first chapati is kept at bottom of the box and the last chapati is kept top in the box. So for serving, the top chapati is served first and so on. Thus bottom chapati is served last. Same thing takes place in data here. The last data is processed first. Physical addresses contains two parts. One is segment address and another is offset. So in total it takes 20-bit registers, 10-bit of segment address and another 10-bit of offset. So thus making it 20-bit. But using segment registers, they use 16-bit of register, that is equal to our word length. That is cuts off 4-bit of data. Pointers and index registers. Pointers and index registers come under the general segment registers, that is SP, BP and SI in the architecture of 8086. SP stands for stack pointer, BP stands for base pointer, SI stands for source index and DI stands for destination index. So SP, stack pointer, pointing to the program stack in stack segment. Here it points to the program. Base pointer, it points to the data used for based indexed or register indirect addressing. Source index, as its name says, it gives index of the source, used for indexed, base indexed and register in indirect addressing, as well as a source data addresses in string manipulation instruction. And DI, destination indexed, used for index, based index and register indirect addressing, as well as a destination data addresses in string manipulation instructions. So now next comes flag registers. The flag registers are placed under the ALU, as you can see here. They are also 16 bytes. So the 8086 flag register contents indicate the results of computation in ALU. It also contains some flag bits to control the CPU operation. These flags are similar to the flags we use in our program. That is, like if condition is true, then flag is 1, else flag is 0. So these flags are similar to our programming flags. We will study about these flags in more detail in architecture of 8086. Next we will be seeing the architecture of 8086 in our next lecture. If you have any doubts, I will clarify them. Please write them into the comment section. Thank you for watching this video, and if you like this video, please press the like button